All right, so let's take a look at that last question on the review, the proof. I decided to keep that as an entirely separate question, so I could just focus on that one idea since it's a topic that tends to cause people a little bit of issue. So let's see what we got here. So in this problem, it says we are given that angle CAD is the same as the measure of angle EAF. So one thing that I have found sometimes can be helpful is to use a little bit of color. I know that CAD is the same as EAF, right? That's what I have. That's what I've given, in fact. So let's go ahead and write that down since we know that's usually where a proof begins, in fact. There's a few times that I've seen that done differently, but the vast majority of proofs begin at that place. Now I'm going to change my color here just to do something, just to demonstrate it. But now it says, let's use that information, excuse me, to prove that CAE, which will be like this angle right here, is the same as DAF, which would be this angle right here. Well, you can kind of see what happened. How would you turn angle CAD into DAE, or sorry, CAE, is I think we would need to add this little angle in the middle. See, if I took the green angle and added a little bit, I could get it into this one. But if I added this, I basically need to add the same thing to both sides, right? So that's what we're going to do. Let's take the measure of the angle CAD and the measure of angle EAF. And to that, let's add this one here in the middle, which is DAE. And I'm going to add that to both sides by the addition property. Now that's kind of important. That's just a property. You can add things to both sides. You can subtract from both sides, divide things on both sides. That's just simple algebra or mathematics ideas. But the geometry kicks in on step number 3. Step number 3 has a little bit of geometry involved in it. And that's because if you took CAD right here and you added it to DAE, which is right here, then the angle addition postulate tells you that if you have two smaller angles that are adjacent, then you could together represent them as the larger angle, which would be CAE. And what I always tell my students is it's really, really important to glance back and see if that's really what we were trying to get to. And I am trying to find out that the angle CAE is in fact the same as DAF. But if you look at DAF is really the angle EAF, the bottom one, plus DAE, this top one right here. Again, we're taking this piece plus this piece. Those are nice adjacent angles. So I could take the two smaller angles and say, hey, they are in fact the same as this larger angle DAF. So the measure of this one is the same as the measure of this one. Now, what you will see in the textbook is they will actually do this one by the segment, the angle addition postulate, and as a separate step, they'll replace this side with this one, and they'll only do one at a time. I choose to say, since the same property being used on both sides, I feel like that's okay. And this problem is now done. But what I will say is sometimes what we might do is instead of asking this, sometimes we might ask a little bit of a different question and change it just a teeny bit. So what if we instead said, I wanted to prove that angle CAE is congruent to angle DAF. Now, again, this is not the question we asked you, but if we did ask you this question, it's not a whole lot harder because what I've established is that I have two angles, which means they are in fact the same shape, the same idea, and their measurements are the same. So if I have two angles, they're the same shape, they're the same size. That means if I cut them out and place them together, they would have to be perfectly identical in every way. And so if we were going to have that next question, then I would be able to say that angle CAE would in fact be congruent to angle DAF. And that is by the definition of congruent angles. Okay. And sometimes we write out the word angle, sometimes we use the symbol for it. But again, this was not the step that we asked for in the proof. That would be what would happen if instead of asking to prove that they were equal, if all I did is I changed it a little teeny bit and said, hey, let's prove that they're in fact congruent. All right, well, hopefully that helps. It's a fairly simple proof, not too bad. Pretty similar to the one that's on the test, I will tell you. So thank you for taking the time to listen, and I hope that was beneficial to you. Okay, I will see you guys back in class or back on campus. Bye-bye.